Hello and welcome to this interesting video on snow. Snow is a particular name given to water crystals as they consolidate and grow on their way to Earth. You may think snow is just frozen water, no different or any more special than ice. This is wrong. Snow is distinct from ice in how it forms as a crystal. This distinction is why there is a myth that no two snow crystals are alike. The way water crystallizes is predictable and reasonably well understood. That understanding has created a great depth to the process that may not be known. Depth is in fact the first consideration. Snow starts as water vapor in the clouds begins to condense. As it cools, it falls to Earth and begins to solidify. This occurs around a solid object that is often only a few microns or thousandths of a millimeter in size. It could be dust or more likely a smaller ice crystal. This initial nucleation point gives rise to 6 arms, and these form the axes of the snowflake. The ice crystals that make up snowflakes are nearly always symmetrical. This forms the well-established patterns. These will often be a result of the way water molecules will arrange themselves in the crystallization process. This results in not only the 6-sided snowflake, but as mentioned, in a predictable way. Hydrogen and water, as it cools, will reform itself in a particular manner. The primary driving force behind this is temperature changes, and to a significantly lesser extent, humidity. But the two will go hand in hand. As the temperature changes, this will more or less dictate the shape of the ice crystal. This is why we see long, needle-like crystal shapes at much colder conditions than the flat, plate-like crystals formed at warmer conditions. The atmospheric conditions are what are needed. Crystals begin to grow their arms in one way or another. This is the addition of more hydrogen and oxygen in the form of water. This can take minutes, seconds, and even less in some cases. As these begin to add on, and they require humidity for this, the crystal grows in a particular way. This will then be somewhat countered by growth in the opposite direction. This begins to form the first 2 arms, and from there, the next 4 start growing. This creates the 6 arms that are needed, and they will then branch off. As each arm experiences the same atmospheric conditions, each arm has exactly the same changes. This leads to differences in structure that are more apparent when looking at the whole crystal. They can appear as simple flakes. This is what you'll often see depicted in the lead up to Christmas. These snowflakes are called dendrites. Then there are more interesting and unusual shapes, including columns and plates. Each of these are generated at different temperatures, that being anything between 0 degrees Celsius and absolute freezing. The crystals typically develop more elaborate structures as they get bigger. This is why smaller crystals tend to be simpler shapes. Columns can turn into something that is like a hollow cylinder. There are voids in each end. There are also instances where they grow into much longer but thin ice needles, often only a few millimeters or fractions of an inch. Then there are the facets. These are the flat surfaces. You can see here what we mean by that. It's the cross-section if you wish. This occurs because of the way crystals will grow. We mentioned in past videos that the way they all join together has the various parts of it interplaying with each other, sharing electrons and bonding. That is needed because it will guide the growth and control it. Once that initial droplet freezes and creates that initial crystal or nucleation point, the facets around this accumulate more and more as they pass through vapor in the air. This vapor cools around the crystal and bonds to it. As the initial crystal is formed, the rounded surfaces are actually very rough on an atomic scale, and so there's greater surface area and interaction with the other vaporized water. This creates regions that are much more attractive for bonding. This is why, rather than forming a orb or spherical shape, snow nearly always forms in at least some sort of geometrical shape that has multiple facets, rather than a sphere. Those flat regions have far fewer chemical bonds and interactivity, and so they rarely get attachments to them, with attachment from water vapor favoring expanding the horizontal plane. After the crystal grows for a short time, the facet surfaces will remain, and these facet surfaces are what allow it to grow outwards rather than thickening. These are also why the arms develop the shapes that they do. There are of course exceptions to every rule. In this case, under very particular circumstances, water molecules will choose to attach themselves to those flat surfaces and form a prism, rather than the flat horizontal surface that we have mentioned so far. This results in the column shapes. Those are the exception, whereas everything else tends to form in a predictable manner. We've mentioned early on that all 6 arms will grow and change in the same way, and this is why you get that symmetry. The reason those arms grow in the first instance is one simple thing. Those initial starting points will poke out just a little bit further than everything else. This results in a preferential chemical gradient that favors diffusion to these points. Being just that little bit more pronounced, or having the other parts just a little bit shorter, means that these areas will get more exposure. More exposure means that they will grow. This makes that growth and difference more pronounced again. This results in further growth, and the other areas not growing. This is why you get the 6 points and the 6 arms that form, whether it is a hexagonal snow crystal or just about anything else. We've spoken a bit about the chemical bonds in particular, but not the detail on it, and that's because this part is somewhat more complex. The whole crystal is interesting, and how it forms is relatively straightforward at a very superficial level. The individual parts of it, though, are more difficult. There is an angle between the atoms in water molecules, primarily the hydrogens and the oxygen, and the way they form a V shape. As it is a V shape, it will eventually have to form in a hexagonal shape. This leads to an ice lattice. If you don't have that shape, the water molecules can't remain stable. This means you wind up with that 6-arm structure every time. The initial crystal, as we mentioned, is likely to form as an ice crystal with a small amount of water freezing. This small frozen water molecule will be a faceted prism, often only tenths of a millimeter in size. This is where we get those pronounced points which will develop into the arms later on that we just mentioned a moment ago. The rest of the time it's going to form into the various shapes that are required. This all owes to the preferential binding to those more pronounced regions. American Scientist has a very good article that explores these and other concepts related to the development of snow as water crystals, the leading hypotheses, and the mechanisms that underlie what is happening in detail, should you wish to read further or have an interest in what is happening. This is just a very broad overview, and please do take a look at their article if you want more information. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.